Good morning, dear students. Once again, for class 9th, chapter is pressure in fluids and atmospheric pressure. So, in my first lecture of this chapter, I told you what is thrust, what is pressure, and some numericals also based on thrust and pressure. The definition of thrust I have told you that thrust is nothing but the weight exerted on the surface of the earth or surface on any object, and pressure is what? The thrust per unit area. I have told you, and one example also I had taken, and I told you when a brick is kept vertically or horizontally or on the basis of the less area or on the basis of the more area, and how the pressure was exerted by that brick. So now today, what factors affect the pressure? We will discuss about what factors affecting the pressure. So the first factor which affect the pressure is the area on which the thrust is applied. Listen carefully. What much area is being covered by the object on which the thrust is being given, you can say. So the first factor on which the pressure depends upon is area of the surface, and the second is the magnitude of the thrust also, obviously. What much weight of the object is there, that also depends upon that how much pressure is being exerted by the object. So for that I have written 2-3 examples. Let us see when the area is same and thrust is different, and when thrust is same and area is different. I hope you will understand and get my point very easily on the basis of these examples. Let us solve this first. I have written thrust of the object be 25 Newton, area covered is 5 meter square, and once again thrust is same 25 Newton square, as I told you that pressure depends upon the area covered. So thrust I have written 25 only, but area is 5 and area is 10. Area is changed. So let us see what happens when area is changed. Pressure is equal to P is equal to thrust upon area, we all know. Thrust I have written is 25 Newton and area I have written is 5 meter square. So if I solve it, 5 5s are, so 5 Newton per meter square, or you can say 5 Pascal is the pressure exerted on the surface of the object by this 25 Newton force is there when thrust is 25 Newton. But when the area is 5 meter square. Now let us check what what pressure does the same object exerts when area is different, when area is just double 10 meter square. Let us see. P is equal to force upon area or thrust upon area. Thrust is same 25 Newton, but now the area is 10 meter square. So if I solve this, we will find 2.5 Newton per meter square. That is now 2.5 Pascal. Now let us compare with the first question. See, thrust, they both are same. Area is 5, area is 10. What happens when area is just double? Whenever the area is just double, you can see the result. What pressure has come? Pressure is 5 Pascal, pressure is 2.5 Pascal. Area is more, pressure is less. Area is less, pressure is more, as you can see. A very small example you can take. Area is less of the nail. It goes inside the wall very easily. But when area is more of, or if you turn the position of the nail, does it goes inside the wall easily? No. Okay. If the knife which you are using is blunt, has gone old, it is quite tough to cut the vegetables easily. When the knife is new, the area is very less, it is very sharp, so it cuts the vegetables very easily. You can check the example with that. And one more example you can take with the help of your school bag. You would have noticed whenever you keep your school bag on your soldiers, you can see the school bags less. You can see the belt is there. That belt is very wide, they make wide, and they fill inside some foams, etc., so that our soldiers do not get injured and we easily can carry our objects or carry our bags. Okay. If area is very less, let us assume we have a thread there only in our bags and our bag is very heavy, and while keeping here on our soldiers the bag, it hurts here when the area is very less, when only rope is there. So that's why the bag makers or the company creates a little bit wide belts here to keep on the on our soldiers, to make it easier, and very easily we put the bag on the soldiers. Okay, so now the first condition, the area depends upon the area on which the thrust is applied. The pressure depends upon the area, and the second one is the magnitude of thrust. If thrust is more, if weight is more, then also the area will be more. The pressure will be more. And if thrust is less, the pressure will be less. Listen carefully. When area is more, the pressure is less. When area is less, pressure is more. And but when thrust is more, pressure is more, thrust is less, pressure is less. Now let us assume. We have assumed already, we have solved the question. So we can say area is indirectly proportional to the pressure, but thrust is directly proportional to the pressure. Area is less, pressure is more. Opposite is there. But if thrust is there more, pressure is more. Thrust is less, pressure is less. Okay. So let us take one more example with that. I have written thrust 40 Newton of F, that is force is 40 Newton, area 5 meter square. So let us find P. P is equal to force upon area. Force is 40 Newton, area is 5 meter square. So easily we can write 5 8 so 8 Newton per meter square, or 8 Pascal is what? Our pressure. In the same way, force is now half, the thrust is half, 20. P is equal to force upon area, and force is 20 Newton, and area is same, 5 meter square. Now we can write 4 Newton per meter square, that is 4 Pascal. As you can see, thrust is 40, pressure is 8. Thrust is 20, pressure is 4, just half. Thrust is half, pressure is half. Thrust is half, pressure is half. Thrust is more, pressure is more. Okay, thrust is more, 20 to 40, 4 to 8. So one easy assumption we can say that pressure is directly proportional to area, indirectly proportional to area and directly proportional to thrust. This line you can note, please. So I have some more examples. Yes, you all have noticed the railway track. On railway track, big heavy, very heavy train goes here and there. Okay, to control the weight of the train on the track, you would have noticed just down the track we are keeping wooden blocks. These days not wooden blocks, cemented heavy blocks are kept, and very nearby so many blocks are kept. Why they are kept? With the help of those, the train track does not goes inside the surface of the earth. Okay, they are very important for the railway tracks. That is why it is very easy for the railway to go, rail or train to go on the railway track. If we are directly keeping the railway track, what will happen? You can assume, if directly the railway or the train is coming on the railway track will go down to the earth, and train will not be able to go quite easily. And now one more example we have is the foundation of buildings. Yes, you would have seen while making the buildings or while making the house, the foundation is being made, and foundation's structure is just like that. You can see on the foundation, the contractor, or you can say the laborers, used to take and make this kind of structure. First of all, concrete on this, fully will concrete, then pillars are there, then only they create this much. Okay, broad space they take, they fill it by concrete, and then afterwards they used to have pillars. On the basis of these pillars, now they used to keep the bricks on it. Okay, and then after they have roofs on it. Okay, if this is not broad, if this area is very less, assume if we are only keeping this brick, this pillar there, what will happen? With the help of this weight, because of this weight, this pillar will go down, and our houses will be cracked, or on earthquakes it will be easily demolished. Okay, So that is why we keep much area or more area downward to the earth to make it safe with the pressure. Less pressure will be there just because we have more area. So this was something about what factors affect upon the pressure, what is the use of thrust and area. When more thrust is there, more pressure will be there. To make it less, we increase the area. Sometimes we have the need of more area, less pressure, and sometimes we need more pressure, and that's why we decrease the area of the object. Okay, so this was all about pressure and thrust. In our next video we will discuss about pressure in fluids and atmospheric pressure, and we have some proofs, we have some derivations to do. Till then, thank you so much, see you soon.